The type of elements. In this little video, I'm going to introduce you to the different kinds of elements that there are and in what categories they are divided. Let's look at the basic category that we are already used to, and those are dimension-wise. So the kind of elements, depending on how many dimensions they are spanning, are divided into zero-dimension elements, one-dimensional elements, two-dimensional elements, and three-dimensional elements. Now, of course, the one that you already are introduced to are the one-dimensional elements. So one-dimensional elements could be trusses, could also be beams. That means they are represented as a wire, and they can have properties in one or two directions, but they can be represented basically as a wire in a finite element program. Now, the zero-dimensional elements are elements that are represented as a point in a finite element program, and they can be considered as a solid mass. So it can just be a mass that is attached to a point, which is a zero-dimensional element. It can be a spring with a certain stiffness which is attached to the ground, which is also considered as a zero-dimensional element, or sometimes a one-dimensional spring. And you can have other point characteristics like damping, etc., which can also be considered as zero-dimensional elements. The most commonly used one is a zero-dimensional mass. Sometimes you want to attach a mass to a certain structure, but you don't want to make a solid part. So for example, if you have a wing and you want to suspend an engine from it, but the engine in details is not what you are looking for in the analysis in terms of results, then you can just replace it by a point mass which represents the mass of the entire engine. Further, you also have two-dimensional elements. Two-dimensional elements can be represented as thin sheets. These sheets can be triangular, they can be rectangular, they can be parallelograms, they can be rhombuses, any shape which basically represents two-dimensional state. So the difference in the way they are set up is that they have to be in the 2D plane. So they are planar elements. Always either if you can think of skins of a wing, of a fuselage, then those are generally considered as two-dimensional elements because their thickness is way smaller than their dimensions of the length and the width. In finite element domain, they are also represented as planar structures or planar features or elements. And just as trusses and beams have two nodes at their two ends, the two-dimensional elements have a minimum number of nodes representing the vertices. So for example, in a triangular element, you have 3 nodes. In a rectangular element, you have 4. Finally, you also have three-dimensional elements. These three-dimensional elements occupy three-dimensional space. So if I consider a triangular structure being extrapolated to a three-dimensional structure, we can either get some kind of a prism, or we can also get a triangular structure just being extruded up in space. So you get kind of another three-dimensional structure. You can also have a hexahedron, which is a rectangular base structure. And these are all three-dimensional elements. All the three-dimensional elements will have as many number of nodes, of course, as a minimum, as the number of vertices. So in a hexahedron, you will end up having 8 nodes for the 8 vertices. Now, these are elements that have been subdivided or categorized according to their dimensionality. But there are also certain types of elements which are not categorized because of their dimensionality, but because of other characteristics. For example, axisymmetric elements. Axisymmetric elements are basically elements which, when rotated about their axes, can form an axisymmetric structure. Now, these kinds of structures we are already introduced to in terms of axisymmetric constraints. So we know that if I have a certain wire structure which looks like this and it is axisymmetric, and there is the axis of axisymmetry, then this structure can actually be rotated about this axes to form a kind of a, that sort of looks like this, right? And this is basically the structure that we want to form completely. But this happens to be a one-dimensional axisymmetric element. In the same way, if we had a similar structure, but that was two-dimensional, so if I had something like this, and this particular element was rotated about a certain axis, and I ended up having a similar structure about an axis, this would end up being a two-dimensional axisymmetric element. So these are axisymmetric elements. You can also have certain elements which are also called curved boundary elements. They are not very different than two-dimensional elements, but they just have a curved boundary. So there's nothing extra that's special about them. For example, I could have a rectangular element, but two of its boundaries are curved. But I would still end up having the same number of nodes, and they can be easily idealized in the finite element analysis program. So this was just a small introduction to the types of elements that are available to you for idealization of a certain structure.